Okay, at noon, ship A is 150 kilometers east of ship B. Ship A is sailing west at 35 kilometers per hour. Ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing? Okay, so ship A, right? Ship A is sailing 35 kilometers per hour west, right? Ship B is sailing north, right? Sailing. Do I want to do that?
What was the topic we learned last year with like the sailing and everything?
Oh my gosh, I hated that. That was so bad.
fun.
It was direction. DMS. We were doing
Yes.
degrees, minutes, seconds.
We were doing bearings,
Bears.
right? The ship B is going north this way, right? Okay. At noon, ship A is 150 kilometers east of ship B. All right. So is that going to be the best way to draw it? I'm not sure from this description. Ship A is, if they start at the same point. I guess they do. Well, no, they don't. At noon, A is 150 kilometers east of B. Okay, so this is not a good drawing. I'm sorry. Okay. I didn't draw it like that in my notes, and I couldn't figure out why. Okay, so at noon, ship A is 150 kilometers east of ship B, right? So 150 kilometers, that's how far apart they are, right? Ship A is sailing west. So ship A is actually going to start going this way, 35 miles per hour, while ship B is traveling north at 25 miles per hour. Okay? They start off 150 kilometers apart. How fast is the distance between the ships changing? So we're actually looking for this distance here. We'll just call it D. Okay. So again, since we're talking east, west, north, we do have a right triangle, right? This is ship B, this is ship A. Okay, ship A is traveling 35 kilometers per hour. Ship B is traveling 25 kilometers per hour. All right, let's do a little figuring here. The distance, okay, all right, let's leave it at that for now. All right, so we know it's a right triangle. So I'm going to say x squared plus y squared equals z squared. Okay, in the previous example, that z was a constant because it was that ladder. Is z a constant this time? No. Let me rename this as z instead of d to be consistent here. This is x and this is y. Okay. So we know, what information do we know? We know dx dt, traveling 35 miles per hour west. I think we want to make that negative, don't we? It's going towards it, yeah, 35 kilometers per hour. And then we know dy dt is 25 kilometers per hour. And what are we looking for? dz dt, yes.
Are you able to show all the lights off? It's hard to see the reflection of the light.
Sure. At t equals 4 hours.
Better?
That one is.
Okay. So let's see here. Let's go ahead and differentiate and see what we have. We may have to do some more figuring. So we have 2x dx dt plus 2y dy dt equals 2z dz dt. Okay, so what are we missing? We're missing our x and y's, right? X, y, and z.
I mean the X.
What's the x?
150.
Is the x 150 at t equals 4?
No.
The x is 150 at t equals 0.
Yeah.
So at t equals 4, right? At t equals 4, right? Let's figure out the x,
Oh, because then you just plug in.
right? So ship A is traveling 35 kilometers per hour this direction. Okay. So in 4 hours, 4 times 35 is 140. Okay. So if he starts 150 kilometers away and he travels 140 kilometers west, then what's the length of side x? 10, right. X equals 150 minus 140. So x equals 10. Okay. We've got x.
She's trying to find where you are. T equals 4. Like that.
Oh.
Wait, why did you simplify?
Because ship A started 150 kilometers away.
Because you're moving towards me.
Yes. And then y will be 25 times 4, which is 100 kilometers. So we have x, right? So we have 2 times x, which is 10, times dx dt, which is negative 35, plus 2 times y, which is 100, times dy dt, which is 25, equals 2 times z. Do we have z? No, we don't. We need to figure out z.
Figured that out. We did X and Y.
Yeah, we've got x and y, so now we have this triangle. We have 10, we have 100, right? So this is z,
Why is 35 negative?
because it's traveling back towards B. When you're traveling to the left, it's negative.
Would south also be negative?
Yes. All right, so we've got 10 squared plus 100 squared equals z squared. So z equals the square root of, what is it going to be? 100 squared. So 1, 2, 3, 4 plus 100, right? So that comes out to 10 square root of 101. Okay, I did that work earlier, so we'll save ourselves some time. So there's my z. So 2z is 10 square root of 101 dz dt. Okay? Right, so the process I used, right, the hardest part was right here, figuring out what was going on. What was the motion going on? What was happening with our motion, right? And sometimes it takes a little trial and error. So when I first started, I was like, well, that doesn't make sense. Doesn't quite work with the whole setup. So you just, you work it until it does work so you can visualize it, okay? And then when we did the differentiation, when we took the derivative, that's when we discovered we had some values that we didn't know. Basically your x, y, and z. But then we had to go back like, can I find x, y, and z? Yes, we can. Okay. All right, so this comes out to, okay, I didn't write it out. Let's see, negative 350 times 2, so negative 700 plus, yes.
Are you going to just divide the two out?
Yeah, we could divide the two. That'll make it easier. Good thinking. Divide the 2 out of there. Yep. So that's going to give me negative 350 plus 2,500 equals 10 square root of 101 dz dt. Okay. 2,150 divided by 10.
It would be 10 off the building. It would be 2. And you divided 2.
Okay, what's going on, ladies?
We were just saying how you could also take it out of 10 and we gotta explain it. Sorry.
Yes, we could also take out a 10. Yep. Okay, so I get dz dt equals 215 over the square root of 101. Don't worry about rationalizing that denominator. You can leave it like that. What's the unit going to be? How fast is the distance changing? So this is a speed. So what do you think it's going to be? Kilometers per hour, right? I absolutely, positively understand and recognize that these are problems that make perfect sense when I do them. But then when you try to do them, all of a sudden you're like, I don't know. I get it. That's why we're doing so many of them.
I
Okay?
don't know how you think like this.
Practice.
The hardest part is finding.
I'm not sure I think at all when I look at these.
Practice. You'll see that it's a certain types of problems that we're going to see over and over again. Okay? Hey, and sometimes I get stumped also. You know, sometimes it happens.
It looks so easy, and then
I
do
know.
it from homework,
I
and
totally
just draw, like,
recognize
really
that.
sad triangle.
Yep.
I'm like, well, now what?
I'll be honest, the triangle ones are the ones I struggle with the most.
I know, and you feel like it'd be the most obvious. It's just like a
Yeah. Okay. So I'd like you to try number 6 by yourself. Try number 6 by yourself.
Are we expected to like put it into like a decimal with a pi or?
No, you can leave pi. Leave it as pi. Yeah. Okay. So they give us the formula, which is nice, right? All right. So I like to draw pictures. Oops. Okay. So I've got this cylinder.
This side, right cylinder, you know.
It's a right circular cylinder. Okay. So we've got a radius and we've got a height.
It's actually a wrong cylinder.
Okay, so dr dt is negative 2. dh dt, positive 5. Good so far?
Yes.
Okay.
I already messed up.
I was like there, but
When the radius is 4 inches and the height is 6 inches, how fast is the volume changing? dv dt when r equals 4 and h equals 6. Okay, v equals pi r squared h. All I've done is all I did was all I have done is to write down the information from the paragraph. I haven't done any calculus or any figuring yet. Okay. Okay, so we're going to take the derivative of v. So dv dt equals the first times the derivative of the second plus the second times the derivative of the first, which is 2 pi r dr dt. Okay, so a lot of people don't do this. This is the way I do it. I take the derivative and then I look to see what information I still need. Okay. A lot of textbooks that you're going to look at will do all that information first, but I think it's hard to have the intuition to know what information you need doing it like that. Okay. I find that this is kind of like my guide. Okay. So I'm looking at this. I'm like, okay, I have R. I have H, right? Do I have a DHDT? I have DRDT. So yeah, we have everything we need. So dVdt equals pi times 16 times 5 plus 6 times 2 pi times 4 times negative 2. All right, 16 times 5, that's 80 pi minus, let's see, 2, 4, 16 times 6 is 96 pi. So that equals negative 19, 16. Where did I get 19?
16.
Negative 16 pi. Let's figure out the units, right? Okay. So let's go back to this. Right. So we have pi r squared dHdt plus 2 pi r h dr dt. So r is in inches. So it's inches squared times dHdt, which is inches per second, plus 2 pi r is inches, h is inches, and dr dt is inches per second. So we can see we have inches cubed per second plus inches cubed per second. So this is inches cubed. Oops, why do I keep doing that? Inches cubed. Come on. Per second. Okay, good? Yes.
Why can't I thought when you use the division pi it's 0.
Where are we talking?
Like the pi r squared.
It's pi r squared h, right? So when I do the derivative of pi r squared, right, we're bringing the 2 in front because this is a constant. So this becomes 2 pi r dr dt.
Like if you put pi to 3 it becomes 6 r, 4 it becomes 0. Okay.
Okay, let's do the next one together. An inverted cone is leaking water at a rate of, okay, so here's my cone. Okay. And it's leaking water out here at a rate of 1 cubic centimeter per minute. Okay, so that would be considered what? If it's leaking, that's negative, and it's dV/dt, right? Negative 1. The cone has a height of 9 centimeters and a diameter of 6 centimeters, which means its radius is what?
3.
3 centimeters. Okay. Find the rate at which the water level is dropping when H equals 3 centimeters. So we're trying to find what? dH dt, yes.
Great job, Faith.
dH dt when H, bless you, is 3 centimeters. So when the height is 3 centimeters, right? When the height is 3 centimeters, what rate is the water level dropping? Okay? Because it's a cone, it's not going to drop at the same rate. Okay, so taking the derivative, dv dt equals, they give us the formula again. Make sure that you memorize these formulas because you need to know them for your exam. Okay, so it's the first 1/3 pi r squared times the derivative of the second, dH dt, plus the second times the derivative of the first. So that'll be 2/3 pi r dr dt. Mm-hmm.
Well, we need to know the formulas for our your test.
Yes. Okay. So right away I see a problem. What's my problem? I don't have dr dt. Is there any way of figuring out dr dt? Yeah?
Wait. I was gonna say solve something using like the 9 and 3, and I was just never mind.
Caitlin?
Can you do like a right triangle if you know the height?
That might give me things like r and h, but it's not going to give me dr dt. It's not going to be rate at which the radius is changing. Yes?
When h equals 9 and r equals 3, but like the dH dt is 0.
Okay, you're on the right track, right? Guys, pay attention. This is the first that we've done like this, okay? So what we're going to do, instead of working with the formula that has both an R and an H in it, I'm going to substitute that R in terms of H. So if I could rewrite my volume formula just using H in there instead of using R, right? So what I'm going to do, I know that when the radius is 3, right, and the height is 9, or I know that when the radius is 3, the height is 9, right? That's my R over H. I have that proportion. So that means I have 3H equals 9R. I'm trying to substitute the R out of there. So R is equal to 3 over 9H, or R equals 1/3 H. I'm going to take this and I'm going to put it into my original formula. Right? So that means I'm going to redo. Why is this not working? Come on. Thank you very much. Cheers. I'm having technical difficulties today.
Oh,
Okay.
so how come you're substituting that?
Okay. So the problem was that when I took the derivative, I had a dr dt that I don't know and I don't have a way of figuring out. So because they gave me the relationship between H and R, I can rewrite my volume formula without an R in there. So I'm going to do 1/3 pi instead of R, we're going to put 1/3 H squared H. Now I've got my formula rewritten, I'm going to be able to solve everything. Let me just clean this up now. Let's see, that's going to be 1/9, so it'll be 1 over 27 pi H to the 3rd. That's going to be the volume formula that I use. Okay. So we've got dv dt equals, let's see, that's pi over 27 times 3h squared dh dt. Come on. Eee! Okay, so, oh my word.
Yeah. Just throw it out the window. Throw it out the window.
What is going on? What in the world?
Ooh. Walking down the street.
Okay, while I'm trying to get my computer to cooperate. Okay. Okay.
And I said, hey.
Okay, so we're going to take a break from related rates. We are going to, let me see here.
So it's just 10 points is probably.
I am planning to have a test on Friday on related rate stuff, but we're going to take a little break from it for now. Okay.
What did Keith Lewis get? He was definitely
What am I doing?
You ever seen Watch?
I'm sorry I didn't tell you
What? Yeah, she didn't tell us.
You had a pop test?
Yeah, and go.
Basically.
Who's your teacher?
Miss Gillette. Wow. Miss Coburn.
I wasn't here the day that we did like the fast track to 5 and the other thing. And
But
so
it
then
was
the
like,
day I
I
came
was
back, I asked you about it because it was on paper. You said don't worry about it. And I had 0. And
Okay.
so should I make that?
So the fast track to 5, you can make up. The other one, I'm going to mark right now as excused. So I don't forget.
Thank you.
I don't really care. I think like everyone's getting like an 80. I had Margie.
So Nick Lucchese got a 90, so if we could get her to give us a 10-point curve, I'd be fine.
I feel like she would.
I don't know.
There, he needs to study.
I think
He
so.
didn't-
But I
no,
was
he-
not
he-
there.
I turned in my 4.4.
Okay.
What we learned? Yeah.
Can you send me an email telling me that?
Okay.
Well, she at least told us on Thursday that we had a test.
Because if she's here for the quarter, I think I'm just gonna go get her this time.
I'm gonna Facebook call her.
Okay, I don't have this on the computer.
Facebook,
Yeah, but last thing I heard was she was
she's not in the hospital.
She is.
She's at
Oh, this thing.
Oh, this is where I said
Yeah, I
Me.
recognize some
Miss Murray, number 9 did not have a graph.
And I just.
I know, I didn't count that one.
Okay.
Oh,
Oh, good heavens.
yeah.
Okay, well, at least I only got 4 of them.
Okay.
Grab that.
I didn't.
That's okay.
What did you get? 90.
How was the wedding?
It was actually awesome.
Oh, these are like good one. I'm the only one I can ask.
Okay.
I could not.
Dang.
Is it pretty good?
Why is this awesome?
Where they?
Oh my god, I took up so much.
No, they both live here.
I'm not here.
Okay, I'm going to give you like a 3-minute break while I take pictures of this so that I can pull it up on the
No
screen.
worries.
Oh no, I think that. Mass exodus, right? Ay.
What's happening?
All right, hurry up and go. I hate it when everybody wanders out of the classroom.
Yeah, take that through highways, but there's no way it's not so bad. It's gone on some. Like the big team's like, I'm a rack. I should have a rack in front of me.
It's so gross.
They were hard. I thought they were holding really much.
You guys gonna pass the
The camera was helping too. embarrassing.
That's not good.
Yeah. Well, the problem is that I thought I was saying them right, but then I would get an answer that didn't look like any of the other answers. So I was like, oh, how else to do it? I first step 5 and I kept my teeth. I thought it was fun. And there was none of the answers. I know. I have to know. You probably have a hacker.
We have 4.
Someone hacked.
Yeah.
When you have a hacker, they use your battery more. You're like sharing your It's probably a person from Russia staring at your. Why did they do this? They want to learn to do calculus.
Miss Marie, can you turn the air down a little bit?
If you have 92.
We're looking for your social security.
That's pretty high.
That's very good.
Are you warm?
Yeah, very. I don't have a jacket on either. I took my jacket off.
This fast?
But it says an A, so it's not gonna put your. Thank you.
What?
I don't. That's.
Nikki's Russian.
It's
What's it?
Oh. Exactly.
All right, let's see, who needs a copy?
She's
Next to me, like, there you go.
Gabby, I'm sending a copy back.
Okay, thank you.
Yeah, text her like you.
Yeah.
You know math. Ask her mom if she knows math. Good mom, you know math.
simple grading.
That's why she likes essential oils.
Nice if I could find my answer.
Not a big essential oil guy. Everyone knows like how it does in your mom would talk her like box. It has like layers of just essential oils. It's so cool. Really? It's like a karaoke. Like slots for them.
She doesn't really use it anymore.
It's preposterous.
Wow. What are these essential oils? What are essential oils even supposed to do?
Cure every disease known to mankind. According to those
I'm losing passion.
What is happening? Because I feel like everything is down.
The internet is really bad today. It's really bad.
How long is this one
Drink it. Drink it.
That's why I was like,
We probably need to like upgrade the plan or something.
Something's definitely wrong because I've had trouble getting in and out of everything today.
I know. Run home doesn't work.
It's so good. Citrus, whatever it's called. It's so good.
Wow.
I know, because I was trying to get on the app, it wouldn't let me. And I was like, please, where's my grade? I check my grade like socially.
What grade were you checking?
I did.
If she would have been already.
Yeah. Yeah, not bad.
It would take that anything. I don't know.
Oh, I bet. What?
Gets upset if I move too fast.
It's kind of like my dog. Can't move or anything. Well, you're like looking at Toby, he is freaked out. Like he just will run away. There's like
Okay, here we go.
Toby will run.
Okay, so put the video back on.
Oh, she knows.
I think the video's been on the whole time. Okay. Okay, so the first one, here we go. Let's pay attention, please. Okay, first, Manny. Thank you. Okay, this is the limit as x approaches infinity, which means all we have to do is look at the leading term in each one. So the bottom has a bigger leading term. So our rule says if the denominator approaches infinity faster, then the limit of the whole thing is 0. Okay. Number 2 is a little bit trickier, right? So this is one that you have to recognize, right? This is the definition of the derivative that we learned in the very beginning, the limit as h approaches 0 of f of x plus h minus f of x over h. That's our definition of the derivative. So what we do is we look at this to identify what f of x is. So we know that f of x is actually the natural log of 2, right? And that way we don't have to work this. We know that we can take the derivative of f of x, right? The derivative of the natural log of x, or u, natural log of u, right? The derivative of the natural log of u is 1 over u du dx, right? Since this is, there's not going to be a du dx there, so it's just going to be 1 over 2. That's going to be the derivative of it. Okay? So our answer should have been B. Okay, that's the quickest way to do that instead of trying to work through with that expression. Okay? So you just have to recognize that that is a derivative. Okay? Yes, sir. You can, but they haven't learned L'Hopital yet. Unless you taught it to them the other day, but we didn't do L'Hopital yet.
You taught it to us, and then I taught it.
Yeah.
You just take the derivative.
Okay, all right, see, that's why we don't want to do that. You don't want to tell them that stuff ahead of time because they get all confused.
Made a lot of sense.
It's too soon.
I just thought it was something I forgot.
Yeah.
Yeah.
I was just like, oh, wait, we learned that?
Okay, focus back up here. Ready? You do have to recognize, right? So, yes, we could take the limit. We can do that. But the idea here is that you recognize this expression as that, which is the derivative. This is really important that you recognize this. This will come up in different places on your exam in different forms. You have to recognize that definition as being the actual derivative. This is equal to f prime of x. Okay? You have to recognize that. Okay, number 3, we're looking for y double prime. So we're going to do y prime, right? Derivative of e to the x is e to the x, so e to the negative x squared. And then we have to take the derivative of this part, which is negative 2x. So we get negative 2x e to the negative x squared. That's y prime. Y double prime, we're going to take the derivative again. So this time it's the first times the derivative of the second plus the second times the derivative of the first. So we already know the derivative of e to the negative x squared because we just did that above. That's negative 2x e to the negative x squared. Right? And then the derivative of negative 2x is negative 2. Okay, so we get y double prime equals 4x squared e to the negative x squared minus 2 e to the negative x squared. Everybody good? Okay, substituting 0 in for x, this whole term right here will zero out, right? Because I'm going to have a 0 there. So it's going to be negative 2e to the 0, which is just negative 2. Okay. Number 4, find the average rate of change. How do we find average rate of change? Slope formula. So this is f of 4 minus f of 1 over 4 minus 1. f of 4 is 6, f of 1 is 2, so we get 4/3. Average rate of change is simply the slope formula. Okay, the next one's trickier. Taking the derivative of h of x. Well, this is a composition function. Composition functions, that's the outside inside. So we do the outside, so right, h prime of x is going to equal g prime of f of x, that's the outside, times the derivative of the inside, which is f prime of x. Right? Anytime you have a composition function, it's the outside-inside rule, or the chain rule. Composition function, we use the chain rule. So h prime of 3, so that's g prime of f of 3 times f prime of 3. So f of 3 is 4. So we're just using our table now. All right, g prime of 4 is 1/2. F prime of 3 is 2. So 1/2 times 2 equals 1. We good so far? Okay. Find the set of x values for which f of f is a relative minimum. How do we find the relative minimum? You look, right, we look at the zeros, right? So they've already given us f prime. They've already given us the derivative. So as soon as I saw that, I took a moment to go back and read the question again, just to make sure that we were actually talking about f and not f prime. And we are, so we're good. It's just that they did one of the steps for me, right? So based on this, what are my critical points? Good. It's going to be x equals 0, -1, and 4. Okay. So I'm going to put those numbers, list them in order. Okay. And we're looking at f prime of x, and then this is f of x. Okay. So let's look at maybe like -2. So I'm going to have a positive, and this is going to be a negative. And this will be it's going to be a negative, but we're squaring it, so it becomes positive. So f prime of x is negative, which means this is decreasing. F of x is decreasing. Okay. Now if I look at between 0 and 1, so I'm going to use -1/2, all right? So I've got a positive. This will be negative, but when we square it, it's positive. So the f prime is positive, which means this is increasing. And we're going to do it one last time. Oh, no, we're going to do 2 more times. Sorry. Okay, I'm going to use 1. So I've got a positive, and a positive. So that's positive. Okay, since it's more common for this to be alternating, I'm going to just double check it again. I used 1, so that gives me a positive. This is definitely positive. This is negative, but when I square it, it's positive. So we're good. We're still positive. Okay, here I'm going to use 5. We have positive, positive, positive. Okay, so the relative minimum. So if this is decreasing, this is increasing. So the relative minimum occurs right here at x equals -1. Everybody understand that? Okay. Number 7, this is just a straight low D high minus high D low over low low. And I got C as my answer.
Yeah. So,
Okay. Okay, number 8, the relative maximum. So we're doing the same thing, only this time we actually have to figure out f of x. So, f prime of x. F prime of x equals the first times the derivative of the second plus the second times the derivative of the first. So I'm going to take e to the negative x out, and that leaves me with negative x plus 1. Right, so this will have no bearing on it. We get x equals 1. That's
Yeah.
Oh, you're asking for the maximum value.
okay. So looking at f prime of x and f of x. Okay. So I don't want to use 0. So I'm going to use negative 1. If I use negative 1, I have negative times a positive. So this is negative, which means we're decreasing. And on the other side of 1, I'll use x equals 2. This is going to be positive, which means I'm increasing. Did I do that right? Oh, I think I made a mistake. Oh, I plugged it into f of x. I'm sorry. Oops. I was looking at the wrong function. F prime of x. Here we go. So I'm looking at e to the negative x times negative x plus 1. So negative 1, this is going to be a positive times a positive, which is positive. And 2 will give me a positive times a negative. Right? So I am definitely going from increasing to decreasing. So it is a relative maximum at x equals 1.
I got more same. I swear to change.
What are you saying?
you got my problem with that.
You got. We put B on this one. That was determined. And you put B and B.
Oh, I know why. B is incorrect. Right? It is a relative maximum when x equals 1, but the question is, what is the maximum value? So when x equals 1, f of 1 equals 1 times e to the negative 1. So 1 over e is the correct answer. That is the actual maximum value. Yeah. Got to be really careful. Okay, last one. Number 9, obviously I forgot to attach the graph.
It's okay, no worries.
Number 10. Okay, what has to happen for the function to be continuous? Well, think about our definition of continuity. Okay, so f of 1 has to exist. The limit from the left has to be equal to the limit from the right. And f of 1 must equal that limit. Okay? So we're looking at x times x minus 1 over x minus 1. So my x minus 1's cancel. So we're looking at f of x equals x. Okay? So what has to happen at x equal 1? So at x equals 1, f of 1 does exist. It equals 1. So that means the limit from the left and the limit from the right have to equal 1, which they do, right? So what must the value equal? F of 1 must be equal to the limit from the left, the limit from the right, which is all 1. Okay? Okay. I am going to just off and on just kind of give you these type of practice tests to keep you fresh on some of your old skills, okay?
It's all good.
Keep you familiar. You do have homework. The homework will be from your homework 4 packet, 4.4. And I would like you to do number 13. Just 13. Friday. Number 13 on the homework 4.4. Yeah. How come?